Let us assume that we have a program, and in the program we have this statement. What happens in the main memory? Now A1 in main memory, this is memory, A1, it will reserve some space, the compiler will reserve some space, and it will put the name A1, A4 and A5. These are 5 elements. Actually all the elements are of the same size, and that number of bytes to be occupied by these elements is determined by the compiler itself. And if I assume that 4 bytes are considered for 4 bytes are taken for integer, then all of them will have 4 bytes, 1 2 3 4, like that. And moreover, this is called identifier. Variable names are called identifiers. Actually, this is the name given to some location inside the memory. It has some location. Let us suppose that the location is address of the first byte is 400, here it is 800, here, right? So these are the addresses assigned to this memory variable. And whenever I want to store any data, what I do, I always give this ampersand symbol, and this ampersand symbol is nothing but address extractor or address operator. So if I say A1, that it implies 400, and this scanf statement, if I write scanf statement, then you must have to, you know that you must have to give ampersand of A1 like this. And if I want to enter 5 elements, then I have to give this statement 5 times ampersand of A5. 5 statements I have to give, and these are scattered. But if I do the same thing in a different way, let us suppose that I have an alternative of this declaration. I do write this statement as integer A5. If I do this, then what happened here, this A will have 5 elements, and each of the elements, since it is of the type integer, it will occupy 4 bytes, 1 2 3 4 and 5. These are 5 elements, and the name common, there will be a common name to all these variables, and here it will be A0 A4, right? 5 elements, and is equivalent to A of 0. A2 is equivalent to A of 1, like this. But however, when I want to read data to these locations, instead of writing 5 different statements, only one statement, scanf %d ampersand of A of I, and I will use a loop, say for loop, integer I is equals to 0, I less than 5, I plus plus, right? And this one will do the same thing as this one, but the advantage here is the code. This code is very compact code. But this is, if I want to declare, say, 100 variables, and if I want to declare all 100 variables in this way, you see what will be the size of the code. That's why the programming language, any programming language, especially here I'm talking about C programming language, C has the concept of array, and this array, it says that instead of declaring the variables individually, let us define it as a group and give a common name, and also use the concept, the index concept of index of array to manipulate the content. If I use array, then we have many benefits. First benefit is the declaration plus accessing elements can be done with a common name. Array helps us in organizing variables or say organizing data in efficient way? If it is so, then array is called a data structure. Array is a data structure. Array is a data structure, and array is considered as the most fundamental linear data structure. For example, suppose we have 7, 6, 9, 8, 10. These are the numbers, and I have I have one problem where I very frequently I need to delete elements, right? I need to delete elements, and whenever I delete, suppose that I want to delete 9. So what I need to do, if I delete 9, this is the array. Normally in array, if you delete element 7 here, 6 here, I want to delete 9. So 8 will come here, 8, 10 will come here, 10, and this place I have to put 0, because it indicates that this is deleted. So one element is deleted. So every time I delete something, you have to move it, you have to move it, you have to move it, and this one will actually consume more time. So sometimes what happened, the array, the concept of array does not meet the requirement of the problem. That's why again this array is extended to another type of data structure. Array is the simplest data structure, which is the most fundamental data structure, and that array may be extended to another form. One of such forms are called stack, and second one is called the queue. It is another linear data structures that is derived from array, basically derived from array. We can derive these two from linked list also, we'll see that later. For the time being, these two, stack and queue, are extended from array. So how this is done, what we do in case of queue, basically we put some restriction. We have, first of all, queue, we have an array, say A10. This is the data structure, but in the data structure I put certain restrictions. What are the restrictions? Only one element can be added or deleted at a time. For if it is so, then we cannot have a statement like this, scanf, right? Second one, if I want to add addition takes place in at the end of the array. Deletion takes place at the beginning. So these three restrictions, if I impose on an array, then that becomes a queue, right? So queue is a special type of array, with restrictions in addition and deletion of elements. In implementing the queue, what I will do, first of all, there will be one array of integers. Let me give the name of the array as queue, and this queue will have certain number of elements, 20. If you go to the main memory, then we will have the array queue 0, 1, 2, 3, 4, 5, that way it will go on. Name of the array is queue, and this is the first location, 1, 2, 3, 4, 5, 6. And after that, since I need to add element at the end of the array, that's why there must be one element which always points to the top, top, and there must be one more element that points to the, say, bottom, you can say bottom, top and bottom, and initially both of them will be pointing to 0. There is no elements, that's why. Now what I will do, I will write a small function. Let me define this function. Here this is the include statement, stdio.h, and these are global declarations. Let me write down a function, say add element, and add element. What I will do, if I add element, that I must have to send what to be added. Let us suppose that, let us say ele is the element to be added, and this is the function prototype, and let me give here void, because if it is void then no data will be returned, right? This is the function. Also let me define one more function, that is called delete element, del element in the queue. And if I delete element, I need not have to specify anything, so no argument to be passed. But however, while deleting the element, I want to see what I have deleted. That's why this function should have one return type. And what it will return, because queue can have only integer data, so integer will be returned. Let me define this main function. What I will do in main, I will see later, but let me write down the function add element. Now instead of add element, what I will do, I will write the name as, I will just give the name of this function as push. I will not tell it as add element. Let me tell it as a push function, push and pop. Same way I will give it pop. So let me write down the push function. What I will do in push, void push, this is the function. So this is called a function prototype, right? This is called a function prototype, and this is actually the declaration statement of the function, and I have to define, this is the definition. What I will do, I'll do nothing, because push function carries one data, right? So here it should be integer element, ele, and simply I will put this data q. It indicates the top of the queue. And what was the restriction? Every element should be added at the top. So what I will do, I will put q top is equals to ele, increment the value, top is equals to top plus 1, top plus also, no difference, but let me do in a very simple way. If I write pop here, the syntax is, prototype is, it should return pop, return one integer. Within this, what I will do, I want to get the value which is pointing by bottom is at this point of time 0. Whatever it is, what I will do, I will take one temporary variable integer, say temp. Temp is equals to q and pointing by bottom here. Let me write down clearly. Temp is equals to q, and within square bracket, that is the position, bottom semicolon. And what I will do, I will delete it, it will go forward again. So bottom is equals to bottom plus 1. Then return what I am supposed to return temp. This is the function, pop function. Now let me come to this main. I call this push function, I call this push function, say 5. I will call once again push function, say 6. I will again call push function 7. Then it will call this function, it will go here. Initially top is equals to 0, it will put 5, now it is 1. Then it will call the second function, it will go here. Then q top, the value of top is 1, q top is equals to element is this time 6. So q1, this one is equals to 6, top will be incremented to 2. Again I am calling push. What it will do, it will call this function, it will put element which is 7, it will put it here and it will increment to 2. Now top is equals to 2 and bottom is equals to still 0. Then let me call this pop function. If I call pop function, this pop function, no arguments is taken by pop, this is pop function, but however it has some return value. If it has a return value, then you must have to have some value somewhere here, let's say x. So I need to declare this integer x, maybe initialize to 0, no need. Then it will call this pop function. So it will go here, it will declare one temp variable here, this is temp, it is declared. Then temp is equals to q of bottom. What is bottom now? It is 0, right? It is 0. Q of bottom. What is q of bottom? Bottom equals to 0. What is this value? This value 5. It will put this 5 in where? Temp. It will put 5 in temp. So now temp is equals to 5, and then it will increment bottom because we cannot come backward. So it will increment bottom means this is 1, this is 1, right? So if this is 1, then after that it will return temp will be returning to x. So this x will have 5 at 5, right? Then let me call again one more pop function. Let us say there is another variable y. Here there is another variable y equals to again pop. That means I'm calling the pop for the second time. Then I will go here into the pop function. I will again declare temp. Previous value of the temp variable will be erased because this is a new declaration, calling it once again. And then I will be doing temp equal to q of bottom. What is bottom now? It is 1 means this time it is 6, and it will put it in temp equals to, now it is 1, it is 6, that's why. Then it will increment the bottom to +1 using +1 plus 1, which becomes 2 now. So it will return temp, so temp will come here, it is 6. Okay, now at this point of time, what is the value of top? Value of top is equals to value of top 2. Value of top is equals to 2, and value of bottom is equals to also 2. Let us see a special situation in the queue. Suppose we have a queue, and initially these are the declarations. We have the declaration for top is equals to 0, and also we have bottom equals to 0. Along with this, we have another declaration of q that we already have seen. Q, say 5 elements maximum, it can have 5 elements in the queue. We have a push function, push integer x. It will put the element on top, and top will be incremented by 1. And we also have the pop function where bottom, that is the element which is pointed by bottom, will be retrieved from the array and it will be stored in temp, and then temp will be returned. Also it will increment bottom. That means every time we add element, the top will be incremented. Every time we delete element, the bottom will be incremented. Now in this queue, let us suppose this is the main function. In the main function, if we write a statement, the first statement is, suppose integer y, and y is equals to pop. And when we call this pop function here, it will go to the function pop, and in the pop what it will do, it will perform all the operations. It will create the temp variable, and from the temp from the queue it will take the value which is pointing by the bottom, and it will be stored in temp variable, and then bottom will be incremented and it will return temp. Now here if I look at the queue, there is no element in the queue. this situation where there is no element in the queue is empty queue, or queue is empty. Empty queue. If we call pop function when the queue is empty, then we should have the provision in the program to inform the user that the queue is empty, this information to be given. So for that, there is one function that we normally write in when we implement a queue, that is called empty or queue empty. That function name can be given either as empty, or sometimes it is also called is empty, or it can be sometimes also referred as queue empty, something like that. But the main purpose of this function is to convey the information that the queue is empty. Now let us suppose that we want to write a function empty. We'll select this name empty. It indicates that the queue is empty. That means if I call this function, then this function should inform the user that currently there is no element in the queue. How to write that? First of all, let me say this. Actually, we can write down either this empty function. This empty function may either return a boolean value, or sometimes if I return some either 0 or 1, then also we can do the operation, or we can accomplish the task. Let us suppose in this case we are designing this empty function. It will return either 0 or 1. Assuming if the queue is empty, it will return 0. That is, we'll write this function in such a way that it will return 0 if empty, or else it will return 1 if not empty. Let us suppose this is the way I want to write down this empty function. In that case, what I can do here, when I can tell that this queue is empty, one way is to, if say top and bottom, if top and bottom both are pointing to the same location, when it can happen, initially this condition is true, because initially both variables are taking zeros. That's why what we can do, when I say if top is equals to bottom, if top equals to bottom, then what we can say, we can write return 0, means the queue is empty. So return 0 if it is empty, else if it is not equal, then we can write return 1. So here it is the end of empty function, and we can write return integer here. This is a return value of return type of the empty function. So now initially this is true, because both top and bottom are holding the value 0. So 0 equals to 0, it will return 0. That means queue is empty. Now let us suppose that we have entered one function push function, push a 4. Suppose push 4 we have executed. We have given the push 4, so it will come to the push function. X will be entered in, 4 will be entered here. This function will be executed, 4 will be inserted here, and now top will be 1. If I call empty function, if I call this function, then it will come here, it will see top is equals to bottom, top is equals to 1, and bottom is equals to 0. So that's why it will not return 0, and it will return 1. That means the queue is not empty, so it satisfies the condition. Now let us suppose that I call this pop function now, pop function, and again I will put it in y. If I call pop function, then what will happen? It will remove the value, it will come this to this function, it will take the value from bottom is equals to 0, so y this temp will be equals to 4, and it will do bottom equals to bottom plus 1. That means this bottom value will be 1 now. Then it will return temp y will hold now 4, and then if I call empty function, now let us suppose that I'm again calling empty function, then it will go here, go to this empty function, it will check top equals to bottom, top is equals to 1 and bottom is also equals to 1, and it will, that's why it will say that queue is empty, so it will return 0. And if I see here queue is empty because this 4 is being popped, and this location, top is pointing to this location and bottom is also pointing to this location, bottom is also pointing to this location, both top and bottom are residing in the same location, that's why queue is, and also the queue is empty. So this function is absolutely correct for specifying whether the queue is empty or not. While calling the function pop, here this statement can be rewritten as if empty, this function will call empty function not equals to 0, then you write down pop, you call this pop function, right? Call this pop function, otherwise don't call this pop function. And there is one more situation where we can have one more function. For example, let us suppose first in the main program I call the push function, push 6. So in that case top will be equals to 0, then in this location it will put 6, it will increment by 1. Then again I call this push function 7, then it will be incremented to 2 and the 7 will be placed here. I call this push function once again with 8, it will put 8 here and it will be incremented to 3, and then again let me call this push function 9 will be placed here, this will be increased to 4, then once more I will call push function, then it will be incremented to 5 and this 9 will be, let us say this is 10 will be inserted here. And now if I call one more push function, say I call the same push function once more with element 12, then I can see here, I can see if I insert one more element, it will go to the 6th location 12, which is actually outside this array, because the queue, the array queue is defined as it can hold only maximum 5 elements. However, by calling this push function, I am violating that rule to be followed, where we cannot insert more than the element, maximum element that it can hold. And that is why this condition where this top is equals to 5, means this 5 is equals to nothing but that is greater than the maximum element. This condition is called queue full condition. And we need to take care of the queue full condition while we are using this push function. So how can we do that? For that we can write a function queue full function, say, and this function as empty function will return either 1 or 0. It will return 1 if we can say, if it will return 1 if the queue is full, and when the queue will be full, if the top is equals to the max value will be coming from here. either we can define a macro, or I can directly write this number defined in declaring the array. So if this happens, then it will return 1, else it will return 0. So this function can be used while calling the function, and that we can do somewhere here also. It is a push function. So before pushing the element, I have to check if q full is equals to 1, then we are not supposed to do anything. Write down q is full, write down, say, printf q full or something kind of this. Else what we can do, else we can perform this operation. So this is another important function that we need to understand while implementing a queue. We have seen a queue, implementation of queue extended from an array, and that queue has basically the four functions. One is push function to insert element, second one is pop function to delete element, third one is empty function to check whether the queue is empty or not, and the final one is called queue full function, which checks whether queue is full or not. So while popping any element or while deleting element, we should use the empty function to check if there is data or not. If there is no data, and then we are not supposed to call this empty function. Again, while entering data, we should check for the queue full function or whether the queue is full or not. If queue is full, then we are not supposed to enter any element. That is all about a queue data structure, the queue.